Hi, we are the Francis Tuttle Technology Center InvenTeam from Oklahoma City, Oklahoma.
The Francis Tuttle InvenTeam has proposed an invention that will disinfect airport bins of harmful bacteria and viruses. Studies have proven that the airport security bin is the most contaminated surface in the entire airport. This surface can be a dangerous vector for contact disease transmission. In this era of globalization, we are increasingly at risk of pandemic-scale events. The device would be a modular design made to adapt to existing airport security lines, both automated and traditional. A titanium dioxide solution spray will produce a photocatalytic oxidation reaction when paired with 3 pulsing UV lamps, resulting in the formation of microbe-seeking hydroxyl radicals. Housed in a reflective aluminum chamber, the system is expected to deliver a UV dosage of 10,000 plus microwatt seconds per centimeter squared to the bin in a span of 5 to 10 seconds. As opposed to existing technology, our design is in the niche of a large-scale cost-to-benefit ratio. This design would protect billions of travelers, at-risk individuals with immunodeficiency, and TSA agents.
Our microbial research was focused on 3 main tasks: identifying the presence of E. coli and Staph aureus on our TSA security bins, testing the antimicrobial properties of a titanium dioxide and UV radiation treatment, and determining the most effective type of UV radiation to use.
The project offered a unique opportunity for Francis Tuttle's engineering and bioscience academies to collaborate, with the engineering side designing the solution and biosciences conducting research. It began by verifying the problem, which included swabbing bins from the local airport. During the brainstorming phase, team members were able to pitch ideas and narrow them down before creating a sketch model, a cheap envisionment of our solution.
Our mock-up was our first working prototype. It was built to produce test results for biosciences. We are fortunate enough to present our prototype to industry partners and collect their feedback. Using this feedback, we were able to create more refined CAD models for our final production model.
This is the prototype that we've built so far, and let me give you a quick rundown. So over on this side, we have the front face and along with the flaps to prevent the light bleed. And in here, we have the conveyor belt that we have linked up with chain that we will eventually have hooked up to a motor to the electronics box here. As you can see, the chain, rotating one of them makes them all rotate. Then we also have the bulb fixtures for the single UV and the double UV respectively up here, along with wires that lead up into the electronics compartment where we have a power expander. We're running a PC power supply, Arduino, breadboard. We got the solenoid over here and a spray nozzle that down here comes out into what you can see. We have compartmentalized the 2 sections, first for spraying, the second for disinfecting using the ultraviolet light.
One goal of the bioscience portion of the team was to test if the device built by the engineers killed bacteria. To do this, lab strain E. coli was diluted 6 times and placed onto 8 nutrient agar plates. 4 plates were treated by the device, while 4 plates were not, and were set aside as controls. All 8 plates were placed in the incubator at 37 degrees Celsius for 24 hours. At 24 hours, the control plates each showed clear bacterial growth, while the treated plates showed almost no growth. This evidence suggests that the device is effective.
The Francis Tuttle Technology Center InvenTeam would like to thank the following for their contributions: Brad Sanders, Jared Keister, Julie Foster, Brian Kitzrow, Sean Brockwell, Paul Crawford of Automatic, the Harrison Ore Company, Anthony Perry of Lemelson MIT, Helen Gowden of Oklahoma City University, and Greg Mullen of Oklahoma City University.